All right, welcome back. Let's continue on. As I was saying, you're going to have a percentage of your containers that need persistent storage. And the extra steps that have to be attached to those containers to do that is we're going to have to do some type of definition to be able to map through to them these things called persistent volumes. So, as it says here, certain, not all, of your Kubernetes workloads are going to require persistent storage. We want that data to persist independent of the pod. So, in order for us to provide persistent storage, Kubernetes has an additional primitive type called persistent volumes that we would need to attach to our pod definition to say, I need a persistent volume attached to this pod. It will then, therefore, retain its state and data even when the pod is deleted or reconfigured. So, vSphere with Tanzu supports that. That's being supported via the creation of these things called first-class disks. So here's my pod. Normally, my pod is going to have a series of disks attached to them, typically two. One will be the container image cache. That's the actual image of the container that we're running. The other one will be an ephemeral disk, which you can think about it as like the C drive. It's going to boot up on that. When we're using persistent volumes, we need another disk getting mapped through here. This will be just like our typical disks in vSphere of the MDK file. However, this disk is going to have a special attribute or names attached to it called a first-class disk. This first-class disk is going to be stored on a particular data store based upon how you created your namespace in which vSphere policies you attach to the namespace. This first-class disk is going to be attached to your pod, and then your pod in turn is going to mount that as a different volume, mounted as a path. And regardless of what happens over here to the pod, you notice I erased the disks over here. This disk is going to persist. Now, when we're doing persistent volumes inside vSphere with Tanzu, we support a volume type or mode referred to as read-write once, which means only one pod can mount that disk. I couldn't have had a second pod over here also mounting it. That's a different style of mode called read-write many. We don't support that, and I'm just going to tell you, you don't want that. Okay, that's not cloud native. You should really only have one pod mounting a disk at a time. You shouldn't have two pods doing it. In order to get that disk mounted into that pod, we're also going to need another definition, which is referred to as a persistent volume claim. This is the actual request that's going to provision the persistent volume object and its matching virtual disk. Again, it's going to be done as a first-class disk. And the beauty of this is you're going to be able to see this as the vSphere administrator inside the vSphere client. So we refer to this claim as being bound to the persistent volume. And you'll see that in the HTML client. So workloads are going to claim the mount to the persistent volume, and then in turn, they're going to be able to access the storage, start reading and writing to it. When a developer deletes the claim, the corresponding persistent volume object and its disk are also deleted. So this needs to be approached with a little bit of caution. Deleting a PVC is effectively the same thing as deleting a virtual machine from disk. In other words, you're not removing it from the inventory, you're deleting it from disk. Normally, when pods are being defined or created inside Kubernetes, you're going to have a manifest file. And in the manifest file for the kind up here, you're typically going to have a type of deployment. In Kubernetes, I can put several different primitive types in a single file by just simply doing dash, 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 and then putting whatever else I want down here. Maybe I want a service down here. And I can keep doing dash, 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 and do a kind and put different primitives inside here. If I wanted to get rid of this, I'm like, yeah, this is mucked up. I don't want this anymore. Whatever this file is called, let's say it's called app1.yaml, I would simply do a kubectl delete -f and point it towards this YAML file, and it would take any of the primitives that it created here, and it would delete them. Okay, good. If this particular pod needs to have access to persistent storage, you probably don't want to do a dash, dash, dash down here and put in a kind type of your PVC inside the file commingled with the other stuff. Why? Because if I ever then said I wanted to delete this, I would be also deleting the PVC, which is the data attached to it. You probably want to get in the habit of having your PVs and your PVCs in separate files, so that if I want to delete the corresponding pod that's claiming it, I could go ahead and delete it, but at least my data is being preserved. Again, if you delete the claim, the corresponding data is going to be deleted. That we're kind of assuming here, you understand, deleting the PVC also is deleting the data. So just a little bit words of warning. This is what the PVC looks like. This is what it looks like. And I'm saying I want to use this particular storage class, and I want this amount of data being allocated to me. So what does that look like inside the vSphere client? If I go to my namespace in the vSphere client and I select my storage tab, I could come over here to my persistent volume claims, and you notice there is the status it's bound, and I could see inside here that it's actually been created. And the beauty of it is I'm just using my vSphere client to manipulate and look at this stuff. Now, I'm not creating it, but I could see that it's in use. Oh, yeah, I got a persistent volume claim here. On the cluster, remember, you're going to have several namespaces inside your vSphere cluster. I don't want to go to each individual namespace and see this. How can I see this cluster-wide? Well, you go to the cluster over here, you go to your monitor tab, and we've got to come all the way down to the bottom to the container volumes. And here I will see all of the PVCs that are in use across the entire cluster. If I wanted to limit it to just a particular namespace, I could just put my namespace filter right inside here, and then it would reduce this down to just the PVCs in a particular namespace. So, how do I see the pod that's actually using it? Well, we need to go a little bit further. Back at this screen over here, if I select this icon, I'll get to this screen here where I select the icon. It's going to take me over to a more detailed page, and I could actually see inside here the pod that's claimed this persistent volume claim. I could go over to my Kubernetes objects, and I could see inside here the namespace that it's being used in. And again, I would be able to see the pod that's consuming it. And I will actually see inside here the persistent volume that's backing it. So all this information I've explained to you is standard Kubernetes. Regardless of where you run Kubernetes at, everything I've discussed here is the same regardless of the platform you're on. The specifics here is how we're implementing via the CNS, the cloud native storage that's plugging into the CSI, and how we're exposing our SPVM policies as storage classes. And then we could use the vSphere client to actually see those persistent volume claims in the respective namespaces or on our cluster. Architecturally, how are we accomplishing this? Well, as you know, up here, we're doing a kubectl apply, and we're applying the specific YAML file that has the corresponding manifest or objects inside of it. I explained to you, you probably should be implementing your PVCs as a separate file, not a combined in a larger file, because if somebody deletes that via that file, the PVC is going away and you don't want to lose data. None of us do. So I apply the via the kubectl command, the manifest file. That is running here on one of my supervisor control plane nodes. One of those control plane nodes is running a service, it's actually a pod, that is the CNS to CSI interface. That's going to pass that information over here to the virtual center server where the CNS is actually running. The CNS would interface over with SPVM to be able to select which disk, which data store we're actually going to put it on. From there, we're going to actually pass the creation of the first class disk over to a physical ESX host that has been chosen that we're going to be running this pod on, or the pod is currently running on. He will actually go in and create the first class disk that will ultimately end up in us talking back to Spherelet on that host to tell Spherelet to go ahead and map the disk through to the pod, because Spherelet is watching over all the vSphere pods that are being ran. He will then report back up to the control plane, the API server, and saying, Kubernetes, we now have a PVC that has been mapped through to this pod. So let's go play with it. And how are we going to do that? We're going to jump into a lab. But to review before we jump into the lab, we talked about the CNS. Again, this is the VMware implementation that's plugging into the CSI container storage interface plugin architecture of Kubernetes. We've explained to you that our VMware storage policies are converted or translated into Kubernetes storage classes. And that's what your developers and people will see in the kubectl CLI, the storage classes. We talked about the characteristics of a persistent volume. This is how we're breaking the normal mode of Kubernetes of having ephemeral or transient storage attached to our pods. We're actually having storage that outlives the pod. And we showed you how you can monitor those persistent volume claims using the vSphere client. So to actually go do this in the lab, which is pretty easy, it's not a complicated one, you're actually going to go ahead, we're giving you the YAML file to create the persistent volume. You're going to go view it in the vSphere client, that persistent volume claim has been created. And then you're going to actually deploy a new vSphere pod deployment that's going to claim that persistent volume claim. In other words, it's going to use it. And then you're going to, just to clean things up, you're going to delete it afterwards. So go ahead, get started on the lab, and I'll see you back after you're done with your lab in our next lesson, which is going to be how does vSphere with Tanzu use NSXT for networking.